Welcome, everyone. Today for the Art Club, I'm going to talk about testing the deployment of our Shiny apps using Posit Connect and comparing that against ShinyAppsIO. For this, I'll be using, of course, the Shiny package, but also Special IBD IC, RS Connect. And then we'll be using something called Posit Connect as well as ShinyAppsIO. So I put here the notes for today. It's actually 8 pages long. So, but that's because there's a few screenshots and stuff. Really, like, I'm not gonna be actively deploying apps. Well, you'll see in a bit. I will, but like, that won't be the main thing. But if you wanted to run some of this code, you would need to install RS Connect. And like, let's say you're running stuff with Special IBD, then you need to install either Special IBD or IC. That will automatically also install the Shiny package. Now, here I'll assume that you know a little bit about what Shiny is, but if you don't, like, it's a way of writing our code to make interactive websites. Now, that our code has to be living on a server that's publicly facing, has basically like a browser window. And so you don't want to be running that on your laptop all the time. So normally you can use different services for deploying your Shiny apps. ShinyAppsIO was the first one that came online I want to say like 8 years ago, maybe more. You can sign up, you can get an account for free. If you get an account for free, you can have up to 5 applications. And they give you 25 active hours. So you can always test some things. Now, if you have an account for free, you can only have machines that have 1 GB of RAM, which might be enough for some things, but for some applications, it won't be enough. Now, when you make an app for your on your computer, you need to have what's called an app.r file. If you have that, and that has a code for running an app, in this case, using, for example, the Special IBD run app function that creates a Shiny app. If you open that script on RStudio, which I have here on the left, that's the exact same code I was showing on Github. That's even the app.r. RStudio recognizes that this is a Shiny app script, and it will show you this little blue dot surrounded by, like, I think 2 hands. And if you haven't done this before, it will say like publish. In this case, since I have already done published the app, it says just republish. So if you click on that, you have to select the app.r script. You can share some data if you want to. So in this case, I could share like that folder, for example. And then you can basically choose what server you want to share it on. That could be like your ShinyAppsIO account. In this case, it's already the Posit account, Posit Connect account, which I'll be talking about later. But you can share it to multiple locations from that. What this will do is, like, it will upload your app.r script as well as any data that you selected. This becomes what's called the Shiny App Bundle. It will detect what versions of packages you have installed in your computer, and then it will upload the data, the script, and also try to install the same set of R packages, the same set of versions that you have on someone else's machine, and then serve the app for you. So that ultimately leads to this app over here, which I want to open in the background. Takes a little bit to load. So that's one example. Another example, this one is this one over here, where for this public repository, we have a directory that has an app.r script, a few files. Some of these are soft links, but if I open the app.r, pretty simple, where like it loads Shiny app, loads a few data set files, appears a few options, then eventually runs the app with this Special IBD run app. So that has been shared over here on ShinyAppsIO also. And while the app loads, I'll just show you the code for loading. Like you could use the publish button from RStudio, or you could also use, in this case, what I have here, deploy script, which uses this function from the RS Connect package called deploy app, where you say like, what is the directory that contains the app.r file, which are the files you want to load. So the script, a few data files, in this case also like a directory that has some documentation files. What is the name? What is your account name at ShinyAppsIO and like the server. Now, when you run this on your computer, it will take a few minutes to run in this case because the files are kind of big. This one over here might be like around a gigabyte or 2 or 3. So it has to load that file to the server. It also has to install all the packages on the server. They've done a lot of improvements over the years using binary packages, but it used to take like half an hour, a full hour sometimes to install all of the packages from scratch. Because Special IBD, as we know, has a lot of dependencies. Like overall, it has 199. So if you're deploying a Special IBD app, it has installed a bunch of stuff. We look at IC, has 120. Some of these ones need to be compiled from source. It can take a while. Even with improvements to using binary packages, it can still take a bit of time to install everything. Now, so that's how you deploy things on Shiny Apps. Sorry, let me actually show you the apps. This is the first one that was loading from this app.r script that I have open on RStudio on the left side. This is an interactive website. You can click on things. What R is running behind the scenes, it interprets the changes that you're requesting. It then computes the results and then updates the little website with the results. So here we can see that this particular version was deployed using the previous version of R 4.3.2. It will look at the version of Special IBD used over here. It's one from close to a year ago, from April 2022. So that's that particular app. You can more or less guess when I deployed it. This other app over here that we were looking at is a different data set, also with that version of R. And I'm going to guess also the same version of Special IBD. The one from April 22nd, 2024. Cool. So these apps, they're there, they work, and we've used them quite a bit. We have around 75, maybe at this point around 80 of them total. And we keep deploying them most of the times, not with the publish button from RStudio, but with the RS Connect deploy app. So those are the two options. Here I have the screenshots that I show you. Now, once you deploy an app, you can log into the admin. At this point, I don't need it. Yeah, so I'll make this a bit bigger. You can log into Shiny Apps to your account there. You have multiple Shiny Apps accounts. So I'll go to the Lever one, go to one of your apps. And here on their settings, there's a few things you can change. On the general settings, you can basically choose the type of computer that you want to use. And the largest one available is 8 gigabytes. And we have access to the best Shiny Apps account that they provide. So the Pro account. So this is as much as we can get. Then if you go to advanced settings, you can change the number of R processes So like that's the number of independent R sessions that are running. Each of those R sessions, you can choose how many connections, browser connections you want them to allow. So since this is an app that uses quite a bit of memory, we are reducing the number of our processes to just one on this computer, with only 2 connections to it for computer, by computer. At the bottom of the settings, there's a number of computers that you can request. They're called instances. So here we say, like, whenever someone connects, we're gonna power up 2 computers at the same time. That's because maybe like there's 2 or 3 people that are maybe trying to look at the data. A maximum, we can have 10 computers. So this kind of gives you an idea of like what is the maximum number of concurrent users that you can support through all of this. Well, you'll need also like to have an account, your username, password. Then to also use the deploy app function from RS Connect, you're going to have to set up a personal access token, configure all of that. So that works pretty well, but then you have to adapt a lot of what you're sharing to this situation where you only have maximum 8 gigabytes. You have to make sure that your app at some point doesn't blow up in memory use, and that it works within those limits. So those are the settings that I discussed. And so you have to keep this in mind of like those 8 gigabytes, they get divided by like the number of processes. Each R session maybe loads some data. Now, if there's multiple connections to the same R session, if they're doing different things, the users, and the different things involve data duplication, then that can also increase memory. So yeah, those are all the things you have to keep in mind. Cool. So that's the world that we've been used to. We've been using for quite a few years. And recently, I was able to test Posit Connect. So Posit Connect is a service by RStudio, now called Posit. The company rebranded themselves a few, maybe 2 years ago or so, maybe 3 at this point. Posit Connect has a lot of features. I'll be talking about how we can deploy apps first. So you want to deploy an app to Posit Connect. You can also use the deploy app function from the RS Connect package or the publish button. With RS Connect deploy app here, it looks really similar to when you deploy things to ShinyAppsIO. You have to give it your account name. So in this case, it's my username for the server, as well as the address of your Posit Connect server. So it's almost, it looks almost identical in terms of what code you're running. To deploy the app, you could also use the publish button if you have an app.r script open on RStudio. Now, those are the same options as Shiny Apps, but there's a new third option. RS Connect package over here has a function that we don't really use when interacting with ShinyAppsIO, and that is this write manifest function. So let's look at an example over here. The write manifest function, the arguments for it are almost the same arguments as the ones for the deploy app function from RS Connect. So you tell it, like, what is the directory where you have an app.r script? What are all the files? So like your R code, as well as any data files or other files you want to share. Once you run this function, what it does is that it creates a file here called manifest.json. This file over here is going to be pretty long, around 5,000 lines long or so, because it lists all of the packages that you need for this app. Basically, RS Connect looks at your app.r script, and from it, it says it looks at all your library calls. or all your like package colon function calls, and it determines what are all the list of packages that you need to install. It figures out where you have currently installed them from. So for example, here, there's a package called annotation. I didn't want to do that. There's a package called annotation DBI that I installed from Bioconductor from this particular location in Bioconductor. This is the exact version of the package that I have installed in my computer. And that's like fairly easy. Now, if I look at spatial IBD, this one I installed from Github with that particular version. But as you know, if you're installing packages from GitHub, the real information is not the version, is actually the GitHub commit information. So you have like on the remote SHA, as well as GitHub SHA-1, you have the actual ID of the commit that identifies what version of the package you installed. So it has all of that. It's a few thousand lines long, 5,000, maybe more. Once you have that manifest.file, now you can configure something on Posit Connect, which if you have a GitHub repository where you have the app.r file as well as the manifest.json file, you can basically configure Posit Connect to say like, hey, I want to check that GitHub repository automatically and get all the files from there. So let me demonstrate that over here. So if you click over here and publish, import from Git, you have to give it the URL of your repository. Normally it has to be public. Of course, you can configure some things to if you want to use a private repository, but that's a bit more advanced. That's a repository I have over here. That's public. You tell it what branch you want to work on. Now, after this, when you click next, it internally does like a full Git clone of the repository before this menu shows up, which means if you're working with a large repository that is like maybe 4 GB big, you'll have to wait quite a while before this menu shows up. But eventually shows up, and it shows you like the directories inside of that repository where it detects that you have an app.r file as well as a manifest.json file. So you'll select one of them, give it a name, and then you can click deploy content. I'm not going to do that because in this particular directory, I've already deployed it. Cool. So that is quite a very different way of deploying apps because you're not creating this like you're not creating this bundle yourself. Like Posit Connect will do it for you. It will like clone the repository. It will look at that manifest.file where you have manifest.json file where you have like all of your R packages. So it has that information. The GitHub repository has the app.r code as well as any data that you want, and then it will do it for you. It will do that deploy bundle for you, so you don't have to wait for the files to update. So I did a small test with this. I made a small repository for testing things. For this small repository has a file here that is maybe 10 megabytes. That's why I put it on GitHub. Has the app.r script, which is just like, oh, let's just read that file and make a few name things. It also runs this initial.r code, and eventually it deploys an app using the IC package. Sorry, it runs an app using that. I wrote this deploy script where like, that's basically where I'm writing the manifest file. I also tested things using like the deploy app. Yeah, we just write manifest. That's all I need here to create the manifest file. So it's a fairly small repository. Posit Connect can quickly ingest all of the information. that leads to this app over here, which I'm going to load. I'm going to close a few tabs in the meantime. So you can see here, like it says like sudo bulk small repo. That's part of the title that I gave it. The app is loading as it usually does, but it wasn't deployed with the deploy app function from RS Connect. It was deployed using this GitHub integration. That is pretty nice and sweet. Now, as part of my tests, I also tried deploying from a large repository, but in this case, this repository has a soft link, and it points to the directory that is like somewhere else. And so like it doesn't really work because what the GitHub integration is doing, it's only deploying the files from the specific directory. In this case, the deploy app K09 directory. It doesn't, the Posit Connect server doesn't have a context of other files outside of it, like in this case, 2 directories up. So that didn't work. Also, like since it's a large repository, it takes quite a bit of time for you to be able to interact with it on the menu and stuff. Cool. So after that, I did a lot more tests on this other repository called Posit Connect ShinyApps. The idea is that this repository is like super light. It only has code and the manifest.json files. But I'm organizing in a way that it mirrors the organization of the different repositories where the data came from. So for example, this spatial HPC, sorry, let me open a different one. There's a spatial amygdala under process data. I created like all the directories that mimic where the actual data lived. So the data that I'm testing here on the original repositories on the process data, Visium, 03 QC metrics. So I'm just mirroring all of that using the file names here or the directory names as documentation of where the data came from. Under code, for some of these ones, I'm just putting a small app.r script and like the code for creating the manifest file. For other ones, let's say, for example, a spatial HPC over here, under code, I had to like actually download the data, download some documentation files. So I have a few more scripts before eventually I get to the app.r file as well as the manifest.json. So this repository at this point is fairly light, and it has a bunch of write manifest scripts, has a bunch of manifest.json files, all of these directories with an app.r script. So if we look at some tests here, like that will be like special IBD app. It has to load the data, etc. It takes a few seconds for it to be ready. So there's quite a few tests that I ran with different types of data sets. We're trying to test some of the largest data sets that we have in different definitions of what largest is. But like they all work over here. Now, Posit Connect will automatically check these repositories every 50 minutes and will automatically update the apps if you have changed anything in those repositories. So let's say you've changed anything on the manifest.json file, it will like detect that things have changed and then it will automatically update, as well as if you've changed things on the app.r scripts or the data files themselves. Cool. So let's do a bit of a live test with this repository called sorry, I forget where I cloned that test. Hey, I'm just going to edit things here on the via GitHub. So this was the IC app, and we have here on the app title, the name that said like small repository. So I'm just going to edit it directly here on GitHub and say something live edit. Make the changes. Boom. So once I've done that, oh, sorry, I'm going to connect to.
So it checks every 15 minutes?
Yeah,
Can you force it to check?
exactly. So I call this one small repo GitHub test. So you can see here, like just a small repo, it has added the command live test. Now, if I go to the information for this app, it says here like the checkbox for checking periodically is active right now. But since I know that I just updated it, I can click on update now. And it says like, oh, there were changes found on the GitHub repository. Let's update things. And so once it loads the data and stuff, we'll see that it says command live test. This one is sorry, live edit. Cool. So that was pretty easy there to force the update. There's a few other configuration options that we see. I mean, you can put like a thumbnail if you want. That's just so that like if you go to the connect list of apps and you click on this view over here, some of them have like images, so you can find what the app was about. Let me go back to small repo GitHub test. Under access, you can decide who do you want to share the app with. So anyone, specific users, those are options that we also had on ShinyAppsIO if people had accounts for ShinyAppsIO. But now there's a new option of saying like individual groups. Sorry, all users was just like people that had an account. Now here you can say like I just wanted with like to share this with like a very small set of collaborators or a user group of collaborators. So that's a new option that Shiny Apps doesn't have. You can change here like what is the actual URL you want to give it. Pretty easy. Now on the runtime, you have a lot of the same options that you had on ShinyAppsIO. So you can choose like what is the number of the maximum number of our sessions, maximum connections per process. So here, like I haven't changed any of the defaults for this. This is a small app, so it's okay, but a lot of people log in. The data is pretty small. I only changed the initial timeout, such that like if it takes a little bit of time to load the data, it won't crash. For this data set, it's so small that I don't need to do that, but like I do this already almost automatically for any other app when we're loading larger files. You can also change this idle timeout, which frustrates a lot of people when they're like, you have the app open, they were doing some things, they get distracted, look back at the website and like the website is dead. So this is something that frustrates a lot of users. So we on ShinyAppsIO, the maximum was 60 seconds that you can enable. Here you can go beyond 60 seconds, but I'm just using the maximums that you had available under Shiny Apps. You can also change the maximum RAM available for this app. And that's because all of these apps are running on the same server. So they're going to be competing for RAM usage. So you could also limit them that way. You can also change who's actually running the code. So that's basically it. Like there's a few more options, but that's basically how it works. So well, live test worked over here. Now, something that's pretty interesting with Posit Connect is that you can also configure the server such that you have SSH access. So that means you can upload data to the server. And that's a different way of coding Shiny Apps, because now you can load data that exists on a full path, instead of relative paths. So let's cool. So the reason why this can be quite a game changer is a lot of times we want to update our apps just because our package itself that we use for the app has just changed. So that means that the app.r file hasn't changed, the data itself hasn't changed. Sometimes we're just changing some things, like I changed right now on the app.r script, which was like the title of the app, or small things like that. But yeah, as with a deploy app function where you're making a bundle, a Shiny app bundle, and uploading the R code, the list of packages you have, and the data. Sometimes the data can take quite a bit of time to load. The packages can take a bit of time to install. So this is greatly frustrating when you are trying to update apps. Now, with Posit Connect here, the admin for Posit Connect gave me a SSH access, so I'm just gonna log in. And we'll see here on that server, like I created a set of directories mimicking the structure that I have on the Posit Connect Shiny Apps repository. And so let's look at spatial amygdala, for example, where I just said that we have things on the process data, Visium03. So that's where I have actually uploaded and some data. Here in this one, there's a few different examples where I was testing a few different things. So you can upload a bunch of files here. Currently, the server we're testing things on has 200 gigabytes of disk space. So if using this structure, you can upload data separately, independently from all of the app configuration. Once you have the files that way, we can then use them in some of our apps. So I'm gonna, I don't think I put the link here, but I'll just go to one of these apps. So let's see this spatial HPC. On that app.r, I have this line over here on line 14 where I give it the path to the hard path here to like this external data. And then I load it. I also made it in such a way that if I'm working on my laptop and it doesn't detect the data, I also have the data on my laptop, so I can also test the apps locally. But that data is like gigging north, so it's not on GitHub. So what I actually did behind the scenes is I downloaded the data from JHPC to my laptop, set it in such a way where I could test that all the code was running locally, and then like uploaded the data from my laptop to the Posit Connect server, make sure that like now it works on the Posit Connect server. So by doing this, just separating the data upload from the app.r code as well as the manifest JSON file. Cool. So that's pretty sweet. I already explained the manifest files. I guess I had in mind like a different order for explaining some of these things. Now let's make actually a test here. Or sorry, I wrote this little R script on the Posit Connect Shiny Apps repository that will find here like all the right manifest.r scripts. That's because I'm using the same file name for all of these scripts. They have like different prefixes, but like allocate all of them. For all of them, I basically just run them with the source function. So I have that open over here on my computer. So in the future, I think we have repositories like this one where we have a bunch of right manifest scripts. You can very easily locate them, then run them. And so for each of those scripts is like finding what are all the dependencies I have and updating the manifest JSON files. So in this case, there's 3 files that got updated. So let me just make a commit saying ran global. I'll make the commit, push, and in a very easy way, I can wait 15 minutes and like 3 apps have been updated. If I had done this in the past, this would have taken maybe 30 to 45 minutes per app to update. Sometimes I would actually open a bunch of different R sessions and try to run them all in parallel in my computer. But each of them took like 30 or 45 minutes to update, and I had to like do a lot of mental organization to make sure I was running the the code that I wanted for each of the apps. Currently, actually, my computer, I will look at if I do like library spatial IBD, and then check with session info. What is the version that I have installed? You'll see here that it says I have it from GitHub from this same commit ID 27db42d. Now, if I go to spatial IBD on GitHub, it will look at the commit history. You'll notice that that one is this one over here from December 16, 2024, is this commit ID 27db42d. Since then, like for example, Nick made a commit where he fixed the bug, although I think that led to some errors. Maybe, I don't know. So what I'm going to do right now is I'm simply going to update the package on my computer. It says like, do I want to install a bunch of other things that are new? For purposes of speed, I'm going to say no right now, but like normally would have said yes. So this is installing the new version of the package. Once this is done, I'm going to restart my R session in a few more seconds. And then after that, I want to run the update manifest code. So let's restart the R session. Run the update manifest. This is running behind the scenes. It takes maybe 3 or 4 seconds per write manifest script. I have 5 of them here, and so all 5 of them got updated. And so now we can see like whether all the scenario that Nick, the bug fix that he introduced, whether it breaks any of these 5 apps. Sometimes we make changes on our package, and you test them on one data set, and everything seems to be working on that one data set, but maybe they don't work on other data sets. And that was quite a frustrating experience because you test it on one data set, you then decide that everything is ready, then you spend 30 to 45 minutes updating each of a set of apps. I will do this for maybe 7 apps that were like our core apps from published data sets. And then later on, someone is like, actually, one of them is not working now because all of the data sets have different properties. I didn't actually show them, but like, let's see. I think I have the links to a few of them here. Yeah. So let me open a few of these apps behind the scenes. I already have that one loaded. So sorry, this is one that I have loaded that has a bunch of capture areas. I don't know the full number. Let me look at one of the grids. So it's around 5 times 5. Has like 26 capture areas or so. Sorry, times like 6. So it has 31 capture areas. So it's a pretty decently large data set. So that was one that we tested. This actually is from the hippocampus that like multiple capture areas have to be generated by donor, but like this particular data set has not been stitched. So it wasn't the ideal test that we wanted to run for that. the spatial amygdala is like that, where it has a bunch of capture areas. This is actually for around 10 donors or so. Each of those donors has a bunch of these capture areas, and the data has been stitched, so we can use some of the features that we have written in the package for data sets like this one. So this data set is different from other data sets. And like some of the code that was written maybe breaks in scenarios like this one compared to the previous one that is the more common one. This one over here is like a very large data set, has 120 capture areas. So sometimes the code works well for a small data set, but you introduce some, if you change something, you might introduce a more copying in memory that just like leads to like the memory blowing up. And that is more noticeable on larger data sets. So all these things are like hard to test. Like with a unit test, you actually have to have an app running with the specific data sets. So right now I like updated 5 apps like super quickly. At some point where if we put all 75 apps that we have on a repository like that, like the one that I'm testing things on, with like running that single script, the one that like checks all of the manifest, write manifest.r scripts, runs each of them, commit, push, even before the 50 minutes are up. If you wanted to update them manually, like if you go and check them, like they will be automatically updated by then. So that is pretty sweet. So yeah, they get checked every 15 minutes. Now, since Posit Connect has to download the files from GitHub, it's best to do all of this on a small repository. This will definitely mean that we'll need to separate code for the analysis of a data set versus the code for deploying apps. They'll have to be in different repositories.
Can you freeze one? I mean, say you've got a dependency that is going to break on one thing but works for the rest. Say just hang off on this one app. Don't update this dependency on this app.
Yeah.
But do it for all the rest.
So if you go to that, let's say you don't want to. I guess this one died. Where it's like you're doing too much stuff. On Posit Connect for each of the apps, you can uncheck the box.
Okay, can you granularly go through and check which ones you want to? That's cool.
Yeah, so if there's some apps that you're like, hey, I want to keep that one frozen, you could do that. Cool. Now, yeah, all of these apps are running on the same server. So here we can see like this particular server has 31 gigs of RAM. This would mean that like if you have a lot of apps, some of them like memory intensive, and you have a lot of users at the same time, then you're running into other types of problems, right? But this can always be beefed up to, I think, I don't know how easy it is to like say like, hey, we have a surge in users. Can we just like beef it up temporarily? I don't know how that's possible, or you have to basically at that point like redeploy everything. So that might be a bit of a tricky thing here with Posit Connect. You can monitor things about like how many connections you have, users, etc. But that's across all of your apps. Something that I'll be looking at a lot is the processes tab, where you can see like all of the different R sessions. Some of these apps, like this one over here that has 120 capture areas, is using 11.3 gigs of RAM right now. I already know like what is like one of the most memory intensive things you can do with the apps. So I've tested that. This data set goes up to 50.7 gigs if you're doing that. But the nice thing you can get out of that is like stuff like this, plus like this, or like I create a PDF that has, I didn't plot all 120, but like I plotted like quite a few of them, right? For a particular gene. So I made a few tests, like for example, this one has the 10 donors, each of them with a bunch of capture areas. I made a little plot over here. It was like, actually, scientifically, this one has a nice quirk, which is each of the capture areas was clustered independently using k-means. But the clusters kind of line up across the capture areas. So, well, I don't know why my Adobe doesn't want to open, but you can see a bit of, you can see for, well, here, like, this one doesn't line up across the bottom capture area and the middle one, but across the middle and the top one, you can see the blue line is up. Over here on the left, you can see blue lining up. So that's a random thing, but it was nice to see. Of course, at higher case, it doesn't happen. Yeah, so those are the things you can check. I overall feel that the memory usage reported here on Posit Connect is higher than the one we saw on Shiny Apps. Because some apps that we know that can only run with maximum 8 gigs of RAM reported a higher usage of RAM here than 8. So I'm a bit confused by that, but well, it's just a little bit different. Cool. So I've shown you some of these things about user access, the RAM. Our server here for testing has 31 gigs of RAM, 200 gigs of disk. All those things might be things you might need to beef up. I also tested using HG5 array for apps that have like a low memory usage, but have most of the data served via disk. There's one particular case that I tested where on my this was like 4 minutes actually. I have like I took some photos and stuff on my own phone for testing this. It's 4 minutes, 45 seconds. So when I run this test locally, for some reason, just waiting for the website to appear takes almost 5 minutes. Once the website has appeared and you click on anything, it takes like that long for it to respond. And then after that, everything is fast. But that was like on my local computer. On the Posit Connect server, it never actually runs. Like one time I did get it to run, but by the time I noticed it, the website had already timed out. I had been waiting for like 10 or 15 minutes. So it doesn't seem that the HG5 array here is working so well. That might be because the special IBD, our package, maybe is triggering in some way a pool of data that then is why like the app is not as responsive for loading up. Once it's loaded, it's pretty fast. Now, I was testing this with the data set that has 120 capture areas, but if you actually put it in a sparse memory version, it's 10 gigs. 10 gigs would have been prohibitive for ShinyAppsIO, but it actually works well for the Posit Connect. So data sets that previously we couldn't make websites for, with Posit Connect, we can actually make websites for. Unless there's always the option of getting an Amazon instance yourself, installing the Shiny server, free version software on it, configuring all of that, which Bill over here has done it for one of our apps. But it's a lot of extra work for deploying something that, like here with Posit Connect, we can see that it's a lot easier to
It's clearly easier.
Yeah. Cool. Yeah. So that data file was like sorry, this other one here, like 15.7, with like a file is like around 5.5 gigabytes estimated with like Lobster. That would have been prohibited also on ShinyAppsIO. We've seen that with ShinyAppsIO, if our data object is over 3 gigs of RAM, typically fails at that point. Because like that's just the data itself. Like once you start doing things to the data, you have multiple copies of some pieces of the data, and then it starts to crash. So yeah, overall, I'm happy with Posit Connect. Of course, I'm a little bit concerned about like what's going to happen when you have like tons of apps on the same server and you suddenly need to like beef up the server.
Don't they have some notion of being able to essentially cluster your Connect servers?
I don't know about that.
Okay.
About that feature. Yeah. So like,
I thought we needed con one for a reason. I'll check on that. I thought there was a way in the back to sort of transparently cluster a number of the servers.
Yeah, that'd be nice.
I thought they support load balancing. That's what you're talking about, right?
Yeah.
Okay. Yeah, I think they mentioned that.
Mhm.
Yeah, but like I don't know how that works with like you uploading the data to the server itself through SSH.
Well, it should be transparent. Well, it depends. Yeah.
We can have a mounting a central location for storage, right? And it should work, right? To share between the servers.
Right. That's the extra bit of configuration it would take to set up a cluster of them. But in theory, that would potentially get around some of the per server worried about getting too crowded on any one. But you know, for a test, we weren't going to set up like 5 of them, right? I mean,
yeah.
already on their template.
Cool. So it sounds like they've already have solutions for all these things. So yeah, I don't know how much it costs, but it is much nicer than ShinyAppsIO, and yeah, it does feel pretty sweet. Imagine in the future where you have like the 75 apps we have right now, or like let's say 100, and you're like, hey, I want to like update all my apps to the latest version of Spatial IBD, and then boom, like 15 minutes later, all of them automatically update after running a small script. Yeah, cost was your question, KJ. Great question. I don't know the answer. Cool. So yeah, I'm pretty satisfied with the tests, and there's a lot more that I think you can do with Posit Connect, but at least for our purposes, I think that's basically the main things. Okay, thank you very much. I'm going to stop the recording. Have a good weekend.